3 was not too bad. Sorry, you could just start finding the derivative from the start there. So you didn't have to change that expression or that function at all. The next one, like with this question, there was a bit of a different type of notation. They use this whole ddt of the function quite a lot, which, to be honest, in like a quick finals, they don't really use this notation that much. I think the textbook is obviously just trying to prepare you for whatever could come up. All right, but they're asking for the derivative of g in terms of t, right? That's what this is saying. If g of t is this. So again, you didn't have to change this at all. It was already written with this negative exponent. So you just apply that rule to each term. So the derivative of g is then equal to that. Unfortunately, guys, whatever notation they've given, you have to use. Okay, you can't change the notation if you don't like the one that they've given. So the next one, the same thing, you didn't have to change this at all. You didn't have to work on the original function at all. So you could just say straight away that the derivative is equal to. And guys, as soon as you actually find the derivative, you drop that notation with the bracket. Okay, so just make sure that you are dropping it at the correct point. So you could have left it as 3/2v with the v next to the fraction, that is fine. But for this one, the negative exponent, you do have to put that at the bottom. All right, d was one that you have to multiply out first. Now, guys, now for this one, you have to multiply out first. You have to do FOIL. So u squared times u to the -2. Remember, guys, when you're multiplying powers with the same basis, you add the exponents together, right? So you'll have to take 2 plus -2, which is 2 minus 2. So that's why that's a 0. You could have written this as 1 right from the start. Then you do the outers, the inners, and then the last. Okay. Then I just rewrote it because you have a 1 minus 1, which is actually 0. Okay, so that whole function is actually just -u squared plus u to the -2. And then you get that when you do the derivative. No questions so far, right? That's fine. No, there was two other ones. Oh, yes, sorry, on the other half. Thank you. Yeah, that's true. E to H is it? Yeah. To G. Yeah, okay, sorry, E to G is on the next, on the other half, yeah. All right, there we have E. So guys, this is a good example of how this notation works, right? You couldn't find the derivative straight away. You first have to write all of these fractions with negative exponents. So while you are still working on it, before you actually find the derivative, you need to keep writing it with this DDR and the brackets. Okay, but then as soon as you are actually deriving, finding the derivative, applying that rule, then you drop that. Okay, so just make sure. I know it is a bit confusing, but it's just like that limit h tends to 0 thing. As soon as you make h equal to 0, you drop them. X is also there at the bottom, and then we have epsilon. So F also saying is also saying you need to find the derivative of that whole function. You didn't have to work on this function at all. It was already written in the correct form, all of the terms, which is, remember, coefficient, variable, exponent. So then you're supposed to multiply, and I'll give you how to multiply by fractions. But if you're not comfortable with doing that in your head, you can also always use the calculator, that's fine. So you do 3 times 3 over 2 is 9 over 2. X to the, this is 1.5, right? Minus 1 is a half. Here you're going to do 3 times a half, so that's 3 over 2. And then a half minus 1 is negative a half. And for this one, you're going to do positive 6 times negative a half. That's where that negative 3 is coming from. And negative a half minus 1 is negative 1.5. Then you just need to take those x's with negative exponents. Alright, G I think was a bit strange just because we were now working with thetas and square roots and stuff. So that's what I did. And guys, again, to be honest, I don't think you'll get something like this in your final exam. But I mean, it's good to be prepared either way. So here they're saying you must find the derivative of h in terms of theta. All right, so you know that theta is the variable. Theta is like the x that we've been using. So here you need to take that exponent to the front, and then you need to minus 1 from the exponent. So root 2 minus 1. Fine if you wrote this in decimal form, no problem with that. Then the derivative of just theta is just 1, right? Because it's theta to the power of 1 here. So you'll take that 1 to the front, you're going to take theta to the 1 minus 1, which is 0. So that whole thing just becomes 1. For this one, you have a negative theta and then a negative root 2. So when you take that negative root 2 to the front, it becomes positive root 2 theta. And now you need to take that and minus 1. Now guys, you can check this on the calculator, but it should make sense that this is going to give you a negative value, right? Negative root 2 minus 1. Those are 2 negatives. If you just want subtracting one from the other. So this whole exponent, you need to make it positive by moving the theta to the bottom. But because the exponent consists of 2 terms, both of those terms are going to change their sign. Okay, it's almost like you're doing this. You're actually saying when you're making, or you can write this as negative root 2 plus 1. Right? Do we agree that this is the same as that? So then you could say that this whole exponent is negative. So when you move it to the bottom, it's just going to lose that line. Okay. So that was the tricky part of this question. So if you got to this line, you would have gotten 3 marks. Okay, but the last mark would have been for putting that exponent or making that positive. Okay, any questions on number 5? Right, 6. Here we have 6A and B. There's just one last line to B, which is down. I'll show you now. So for 6A, you needed to obviously write that first. Just change it to a negative exponent, and then x dash x is in it. I just wrote the question down. Okay, there's the final line of 16. Are we all done with A? Can I move up? All right, now C was a little bit more difficult because they had a square root of x cubed at the bottom, and I think many of you forgot how to do that conversion. So just remember that that rule is if you have a to the power of m in the square root, or not square root, sorry, the root, whatever it is, the nth root in this case, then that is equal to a to the power of m over n. The exponent inside the term always becomes the numerator. And the number on the outside, which if it's a square root, there's actually a 2 there, right? We just don't write that 2. So that then becomes the denominator. Maybe just write that down next to this example, because quite a few of you asked me that. Not yesterday, I'll try it. It's something that we don't use often. Okay, we did it in grade 11, right, at the beginning of the year, but now we see that it's coming in here. So it is something that you need to know. Usually it's just the square root, which we all know is x to the half, but this is the actual theory. Okay, so that is why when I split this fraction up, I wrote them both over x to the 3 over 2. So this is x to the 3 becomes the numerator, and 2 would be on the outside. So if there's no number in there, that's a 2. So the 2 would be at the bottom. Okay, so when you're splitting that fraction up, you are writing both of them over x to the 3 over 2. So the first term gives you a 1, which is nice. And the next term, remember when you are dividing, you have the same basis. You say top exponent minus bottom exponent. So this is a half minus 1.5, guys. You can also obviously type it into the calculator. A half minus 1.5 is just negative 1. Okay, so when you simplify this, it's actually not as complicated as it looks in the beginning. The derivative of a constant term is just 0. And for this one, you have a negative 1 there, you move the negative 1 to the front, it becomes positive 1, and you minus 1 from the exponent. So you are left with 1 over x squared for that one. So like in this case, you would probably get 2 marks for this line, right? A mark for each of those terms, and then a mark for the derivative, and then a mark for the final answer. That would be a full mark question. Final answer? Any questions? All right, D is there at the bottom. D also wasn't bad. You just have to multiply those brackets out. So it's fine if you wrote them as 2 separate brackets and FOILed out. But that is what you would get. 9x to the 4 minus 6x cubed plus x squared. And then you just find the derivative of those. Okay, sure. Can I move on? Okay, there is E and F. What are they? Yeah, for F, you can just ignore this. I was just like doing the multiplication here. Remember that the square root of x is x to the half. So when you are FOILing out, you have to do x squared times x to the half for the outers and then for the inners, right? Which is where I got this from. So that would be what you get there. So remember, if you have x squared times x to the half, I think, yeah, one of them will be negative in both cases. Remember, you have the same basis, so you're going to have to add those exponents together. So 2 plus a half. 2.5, that's 5 over 2. Okay, so that's why my middle term has an exponent of 5 over 2 there. So guys, I almost feel like finding the derivative is the least complicated part of these questions, right? It's actually all the algebra stuff that you need to remember. So they can use these derivative questions to test a lot of different algebra stuff in one question. Okay, almost done. There is G. So for G, you just split the fraction up. I didn't actually show that step, so you would have to do this over 4x squared. No, yeah, 2x to the 5 over 4x squared minus 3x to the 3 over 4x squared. That's how I got those two terms.
And they made it the capital. So you got 2 of the x over 2 minus 3x over 4. And then I put it together, so then I got 2x minus 3x over 4.
Okay.
And I times it with the by the combination. We have the function of the quadrant. To make it like 1, it comes by quarter.
Mhm.
I got 2 minus 3 over 2.
Don't you like to simplify it?
But I think it's real.
So what you need to do is you just need separate terms. That's the thing. So I think what you were doing was trying to not have a denominator of 4, I guess.
Yeah.
But like Robin is saying, like you can have a denominator of 4. So
yeah,
yeah, in this case, the simplification is coefficient variable exponent. So that's why I'm not even writing it as x cubed over 2 because I want it off as my coefficient. So I'll have to take a look at that once we maybe. Yeah, it sounds like we did extra stuff. Okay, let's look at H. And I think that possibly in H, some of you forgot these brackets. As I was doing, I was like, that looks like something that might happen, okay? You are minusing this whole fraction, right? So when you split the fraction up, you have to minus both of those terms that you're splitting it up into. Okay, because you are minusing x squared over x squared, but you are also minusing negative 2x over x squared. So make sure that you are putting brackets around that when you're splitting the fraction up. That is important. Very common mistake though. Robin? Yes, you could have done that. Yeah, you could have, instead of splitting it up, you could have factorized at the top, yeah. But then what you left with after you factorize, you also have to put that in there. After you cancel off, yes. Okay, so maybe you might have a sign mistake here. If your final fraction is a positive fraction, then it's because of that bracket. Right, so this is supposed to be plus 2x to the negative 1. So then when you do the derivative, it's going to be minus 2x to the negative 2. That was the last one, hey? I think so. I can show you quickly some examples from past papers. Okay, guys, just quickly as an example. Can we listen up, please? This is last year's end of year exam. So you can see there from first principles, is they've given you 2x squared minus 3x. So that's that limit h tends to 0 thing, 5 marks. Okay. Then here, this is a very straightforward one, right? 9.2.1. That's very easy. You can see that it's 3 marks. So you will get a mark for each term of the derivative. So that is just going to be 20x to the 4 minus 24x cubed plus 3. Right? Straightforward. You don't have to do anything to that function before you find the derivative. Then the next one is a bit more complicated. So it's negative x to the, what is this going to be? 1 over 3. Hey, the exponent of x inside the third is 1. And the number on the outside is 3. So this is going to be negative x to the 1 over 3 over 2. So guys, I would suggest that you write that as negative a half x to the 1/3, right? So that you have your coefficient and your variable and your exponent. And then this one you would have to square out, but it's just going to be 1/9 x squared, which you can then write as 1/9 x to the -2, right? And then find the derivative of each of them. So let's see, how many marks is that? 4 marks. So you'll probably get a mark for simplifying this, writing this term in the correct form, a mark for writing that term in the correct form, and a mark for each of the, maybe it will be 1 mark for getting them both in the correct form, 1 mark for each of the derivatives, and then 1 mark for the final answer where you put your negative exponents and make them positive. But that's basically it. Then the rest of the types of questions where they are testing derivatives is like this kind of thing. We're also going to get to this. This is a cubic graph. We use derivatives to draw this. And then this was not a very nice question. When we discussed it, we always have like a memo discussion after the papers are written. This was an application of calculus question, but it was very ambiguous. So yeah, people complain about this question. And that's basically it for calculus, really. Let me just check. That's finance. Sometimes they bring some calculus stuff into the functions questions, but we will look at that still. Yeah, that was it. Let me quickly look at the 2021. Okay. Thank you, thank you. This is the 2020 paper, the calculus question. So again, first principles, 5 marks, same kind of thing. For this one, it's similar to the second one, right? With this is going to be x to the 2/5 plus x cubed, and then you just find the derivative of each. And then for the last one, here you would have to factorize. Okay, so at the top you have a difference of 2 squares. At the bottom you can take out 2 as a common factor, and you will then be able to cancel some stuff out and then find the derivative. So that was 3 marks and 4 marks again. Okay. This is just saying because when you factorize this, you're going to get 2x plus 3 as your denominator, your bracket. So they're just saying that because if x is -3/2, that will make your denominator 0. So they're just saying x is not -3/2. You don't have to worry about that concept. Yeah. But that's something that you'll be able to cancel out anyway. All right, so that kind of thing, guys. All right, we are doing something new today, an application of calculus. So, thank you. All right, the new heading, finding the equation of a tangent to a curve. Write that down. So guys, this section, this heading, the section that we're going to do today, these are the last types of sections that will be in your case on the 11th of May. So everything we do after this note will not be in the test. Okay, so everything for calculus that you've done up to now. No, we're going to do cubic graphs before you actually do your test, but cubic graphs won't be in the test. So it's just going to be, what have we done? So derivative rules, first principles, what else? Oh, average gradient, we did that stuff, which is easy, right? It's just basically the gradient between 2 points. And then this, not finding the equation of a tangent to a curve. Factorizing cubics also you will have to be able to do. Yes. I mean, in the case I yeah, but I just need for the calculus section, it's just both things. But I have made sure that we do all the stuff that will be in the test first before we go on to other stuff. So, okay. Calculus and trade, yes, but we're going to do more calculus after this note. But anything after this note will not be in the test. So maybe just write at the next to the heading or something. Up until here for test or something like that. And including. Yeah. So guys, just for that test, while we're on the topic of it, you are allowed to bring in a test sheet, but you are still going to have the formula sheet. So please don't double up on stuff that's on the formula sheet anyway and put that on your test sheet. But if you are worried, because you know the formula sheet that I gave you with all the formulas like labeled, you're obviously not going to get that one. So maybe if you're worried that you might not be able to identify any formulas, you can put those on the test sheet. But stuff like when I write down like the steps now to find the equation of a tangent, that kind of thing you can put on your formula sheet. Maybe examples, not the formula sheet, sorry, your script sheet. Maybe examples. Yeah, anything that you think will help you during the test. Oh, 1 and 4, but it can be double-sided. Guys, it has to be in your handwriting. Please, it can't be a digital thing. You have to have your own one, obviously. You can't photocopy someone else's because then that defeats the whole purpose. Yeah. I suppose if you want to do like a little like cut and paste kind of thing. Like if you want to maybe take this formula sheet and you just want to cut off like the bits and stick it on, it's fine. As long as it's not like, as long as I can see that you stuck it there yourself, if that makes sense. So don't like scan it in and print it. Yeah. And then you could yeah, that's not really the point. The point is that you actually take time to like summarize and make the notes. Yeah, that's the whole. Oh, okay. Okay, guys, let's get back to this part. All right. Okay, let's just remember one thing that we are going to use. The derivative of a function is the gradient of the tangent to that function at a specific point. We have written that down before. I'm thinking back to when I gave you that handout. Remember when we found the formula for that limit h tends to 0 thing? We wrote it like right at the top of that first page. We also highlighted it on the second page of it. And we have mentioned this before, but we haven't actually used it. Okay, so we're just going to go straight into some examples and then you'll see how we are going to use this. So guys, basically what I'm saying here in this remember bit is that when we need to find the gradient of the tangent, we're going to have to find the derivative of the function. Okay, so we are going to do it now in the examples, but you can maybe just highlight, oh, that's what to do. You can just highlight derivative of the function. and gradient of the tangent. Okay, so that is what we're going to do every single time. Remember, what kind of graph is a tangent always? It's always a straight line. So we remember that a straight line has the standard form y equals mx plus c. So we're going to have to find the m value and the c value. Okay, so this is how we're going to find the m value always. If you want to, you can write a little m there at the top. Right, that is going to be how we're going to find m of the tangent always by finding the derivative of the function. Okay, first example, find the equation of the tangent Okay, so find the equation of the tangent to the graph of the function, which is f, and they've given us the equation of that function at the point where x is equal to 2. Okay, now guys, what I just suggest is just for the first one, we just write y equals mx plus c. That's what we're going to have to do. Okay, we need to find that type of equation. Tangent is always a straight line, so it's always going to have that type of equation. So the gradient is going to be equal to the derivative where x is equal to 2. So I'm writing it like that. All right, f dash, we know that that is the derivative of x. And now I'm putting a 2 in the place of x. Where did I get that 2 from? They're telling us that the point of contact, right, the point where this tangent is drawn is where x is equal to 2. Okay, so we call that the point of contact, the x value, at least the point of contact. Okay, so let's first just find the derivative and then we're going to sub in 2 points. Okay, so the derivative of the function is f dash x, and this is a very easy one to find, right? Because this is the equation. What type of graph is this? Negative x squared plus 2x plus 3. It's a parabola, right? The downward facing one. Do we agree? Because the a value is negative. We have this kind of shape of the original function. And then where x is 2, I'm not sure where exactly that is on the graph. Let's say it's over here. We have a tangent. Okay, we're finding the equation of this tangent now. All right. So what is the derivative of negative x squared? Negative 2x. You take the exponent to the front, multiplied by the negative 1 that is there. Then you're going to say x to the 2 minus 1. Minus 1 from that exponent. Plus the derivative of 2x is just 2. And what is the derivative of 3? 0. Okay, so this is the derivative. Now guys, this actually is like a formula for the gradient of any tangent to this graph. All right, but how am I going to get the gradient of my specific tangent? By subbing in x equals 2. Okay, so we can add that as a little note. This is the gradient of, let's rather say every tangent. Did I say any or every? So it's any tangent to this curve. Now the gradient of our tangent, the one that we are finding, is where x is equal to 2. So that's why there is an x in that gradient formula. So now we're going to say f dash of 2 is equal to negative 2 times 2 instead of x plus 2. Sorry, we've got the 2 there. You see, I'm just replacing the x with the 2. Right, and that 2 we're getting from what they're telling us. Guys, they're going to have to tell you what the x value is where that tangent is touching. Okay. So what's that answer? This is negative 4 plus 2. So this is negative 2. Okay, so we have a straight line, a tangent with a negative gradient. So it is a tangent that's sloping downwards. So therefore, we know that our equation is going to look something like this, negative 2x plus c. Right, we found the gradient. Just remember, guys, always gradient is tangent. The derivative is gradient of tangent. Sorry, not gradient is tangent. Derivative is gradient of tangent. Okay, which is what we highlighted there at the top. Okay, so we found the gradient of the tangent. Now we still need to find c. Now, what do we need in order to find c? A point. Hey, we need to sub in a point into that equation. Well, guys, they didn't give us a point specifically, but they have given us an x value here. Remember, guys, what point must I sub into an equation in order to get the equation of a graph? The point has to lie on that graph, right? So if I want to sub in a point that will give me this equation, I can't sub in any point. It has to be a point on this line. All right? So we are going to have to find the y value that goes along with this x value. Okay, this x equals 2 is a point that lies on the tangent. Do you agree with that? It's a point that's on the curve and it's on the tangent. Okay. If you just take any point on this curve, it's not going to lie on that tangent. All right. We're not finding the equation of the curve. We're finding the equation of the tangent. The only point that we have that actually lies on that tangent is the point of contact. All right. So we need to find that y value. And right here, point of contact. So the x value is 2. How am I going to find the y value? I'm going to sub it into the function, right? This point of contact not only lies on the tangent, but also on the parabola. It's the point on the parabola where that tangent actually touches. Okay, so the point of contact, x is equal to 2. So y is going to be negative 2 squared plus 2 times 2 plus 3. Okay, so what is it? Negative 4 plus 4, that's 0, plus 3 is 3. So the point of contact is the point 2, 3. I'm going to make a little note next to it. This point lies on the parabola and the tangent. In order to find the equation of the tangent, we have to sub in a point that lies on the tangent. And the only point that we have is that point of contact. So we're going to sub in the point 2, 3 into this formula and then solve for c. All right, then we have our equation. So let's do that. It's a good idea, guys, always to just show which point you're actually subbing in. So just write 2, 3, and subbing it into that equation there. I'm just going to put the right-hand side on the left so that my C is on the left-hand side. So it's negative 2x, but the x value is now 2 here. So 2 plus C is equal to y, which is 3. I've just swapped the sides around, yes? Yes, you can use the other formula, yeah, if you want to. Y minus y1 equals mx minus x1, yeah? Okay, so this is negative 4 plus C equal to 3. So C is going to be 7. All right, so what is the equation of this tangent? Yes, good. Y equals negative 2x plus 7. Any questions, guys? I'm just going to write down the steps quickly so that we have them written down. And I did say examples and number 1, sorry, but number 2 is like a reversal of it. And I actually think you must first practice this. So my apologies. So I'm just going to write here steps. Finding the equation of a tangent. Okay, the first thing that we did was we found the derivative of the function, right? So that's the first thing. Find the derivative of the function. And guys, that will get you marks depending on how complicated the function is, right? If it's a very difficult function, you might get 2 or 3 marks just for getting the derivative. If it's a simple one, you might get 1 mark for that, okay, but that's at least a mark. Yeah, some credit for what you've done. All right, so that was step 1. Step 2 is then sub in the x value of the point of contact. If they're asking you to find the equation of the tangent, yes. Yeah, so the second example, which we'll do tomorrow, is where they've given you some information about the equation and you must find the point of contact. Yeah, so they can reverse and as well. But just for finding the equation, they will give you the x value of that point. And then this, no, I think not write it like that, sorry. Just put in brackets, that is then m. Okay, that is the gradient. Once you've done that, you have the value of the gradient. Then step 3, you will sometimes have to do, other times not. In our question, they just gave us the x value of the point of contact. All right, so before we could sub that point in, we had to find the y value of the point of contact. But sometimes, guys, will just give you the point, right? They could have also just said at the point 2, 3. All right, then you don't have to find that y value. But sometimes, so I'm going to say, if not given, find the y value of the point of contact. Yeah. By subbing X value into equation of function. Mistake 4. Step 4 is then sub the point of contact into the equation of the tangent to find C. Right, and those are the steps that you will always have to follow when you're asking to find the equation of the tangent. Like I said, tomorrow we'll do an example where it's the other way around, where you actually find the point of contact. They've given you the tangent, for example. Maybe we should just add here somewhere y equals mx plus c. The tangent will always have that form. Oh, sorry, here we go. So when I'm talking about m and c, that is obviously what I'm supposed to. Okay, are there any questions on that side? You're just going to practice a few of these on your own for homework. So exercise 8.7, and it's just the same method over and over. You're not going to do anything extra. It's on page 207. Just 2, B, and C. All right, so just 2 of these questions. It's not a lot. You can actually even finish it now in 10 minutes if you're there. Yeah, more than one. Oh, you don't have math tomorrow on Wednesday. Oh dear, on Thursday. On Thursday. Like if I do one page blank, the next example, would that be enough there? Yeah, more than enough. It's probably gonna be. Yeah, it is a longer example than the one we just did. So yeah, one page will be fine. Okay.